Wow, I was not expecting this. We got the results in from our carburetor testing here with Joseph Nowak. You won't believe how much this picked up. Okay, so I just got this carburetor back. Now, for all of you who don't know, this is our 600 Holley that we are using as a test mule, essentially, to try all little bits and tricks and whatnot in order to improve its performance, right? And we're able to judge how well we're doing with another channel as a collaborative effort, right? With Joseph Nowak. He has a channel up on his, no, he has a video up on his channel, right? Where he's flow testing this thing, stock versus our modifications, which we'll get into in a second. You won't, it picked up a significant amount of CFM, way more than I was anticipating it would.
Yeah, it just doesn't make any sense. It's like not real life. No. But it did it.
I highly encourage you to watch that video. It's linked in the description to get the full test results of this bad boy, because let me tell you, the results are impressive. Far more impressive than I was anticipating. So let's go over exactly what we did to this thing to get those results in the first place. Okay, so let me run through exactly what we did to this bad boy, for those who have not seen the previous video in which we actually modified it. Now, clearly, it had a choke horn on it, which we have then removed, cut down. But we didn't just cut it down, we actually tapered it. As you can see, we ported the inside edge right here, right? So otherwise, it's just a flat edge, and, well, you know, flat edges are not very good for flow. So we ported the mouth of the actual choke tower that we cut down. Then we came in here, and as you can see, we did a little work around these air bleeds right here, right? We tried to taper it down and thin them down as much as we possibly could, okay, to try to, you know, get rid of all this sharp edges. We tapered, you know, radiused this back edge here, because that was just a big gnarly flat edge, obviously not on that side, but on this side, okay. And then additionally, I also not only ported this, but I ported this actual air cleaner ring, and it kind of leads down into here too. So ported around this air cleaner ring all the way around, okay, up until around here, because at that point didn't really matter anymore. And then we radiused this right there. Okay, so that's all the modifications we did up on top. Now we'll flip her over, and as you can see, we did a very half-ass effort at thinning down these throttle shafts there. Very minimal effort. Also, minimal effort at shaving down the heads of the screws holding the butterflies in. I mean, you could go a whole lot further with that whole thing than we did. And last but not least, for this side, we, what is it? Tapered? I guess tapered would be a word. Knife edged, that's the word. These butterflies down here. Can I get a better view of that? Yeah, I mean, you can kind of see we did that right there. Did it on this side on the bottom and that side on the top. Okay. Then the last, very last thing we did, which I don't know if we'll be able to see, but I came into the actual venturi itself and removed, there was a big ledge right here, core shift, where the top of the core was not matching the bottom of the core, and it left a ridge right here, which we took care of. Flattened all that out. Those are all the modifications we really did to this thing. Very minor for how much it picked up. Again, go watch that video, because The whole point of the collaboration is, he gets a little something from me, I get a little something from him, right? He, is the implement of able to be testing what I'm doing, but what I can give to him is, viewers, right? Go watch, Okay, but besides the point, now that are done with stage 1, what is stage 2, right? What are we doing next with this thing? We've done the basics. So what's next? Now we got to go into a more advanced, level of modification. So, I mean, it's clear what we got to do now, right? JB Weld. Okay, maybe it's not so clear. Let's go over what I'm thinking. Okay, so now for stage 2, we have to set our goals here. Ultimate CFM, mind you, we've already gained far more CFM out of this thing than I thought we were going to in this initial stage. I'll actually be curious to see how much more CFM we gain from this second stage, because I'm not worried about ultimate CFM. I'm worried about very good booster signal to go along with our CFM. Because really, if I wanted ultimate CFM, I would just take these venturis and make them bigger, right? I mean, that would easily let more air in. That would be gaining CFM. That's the easy way to go about it. It's just making it a bigger carburetor at that point, bigger venturis, right? That's the simple answer. But here's the problem with that. You make these venturis bigger, there's more area around the venturi. That's more airflow that can get past the booster. Booster signal is my main concern. Because the booster signal is really what gives the carburetor its functionality, its responsiveness. If you don't have very good booster signal, it doesn't matter how much CFM you're flowing, the carburetor is not actually doing a good job because it is not atomizing the fuel going into your intake, right? So I want to worry about booster signal before we worry about ultimate CFM. What are some of the things that inhibits booster signal though? Well, like I already said, any air that can get around the booster, okay, not flowing through the booster, but can get around the booster, is losing booster signal, right? That's what we're going to try and attempt to cure with this stage 2 up on top here. Now, we are going to cut out these crossover tubes here. Well, it's not really a tube, it's well, you know what it is. The straight leg boosters all have them. We're going to cut that out. Now, a lot of the times, when you cut this out, yes, you will gain more CFM, but you will lose booster signal. And that is because, if we come down here, we notice the design of the straight leg booster sticks straight out. The actual orifice that you're trying to siphon fuel out of is so far above the venturi opening that it does not have very good signal whatsoever. That is why a down leg booster, right, it drops the booster down into the venturi because that's where the airspeed is the highest. That's why down leg boosters have way better signal and they don't have that crossover pipe, right? When you get rid of the crossover pipe in these straight legs, you kind of lose out on the actual suction happening, because more air is coming through, but it's not necessarily pulling fuel out. You know, this crossover creates more of a suction down low, and that suction actually helps get the fuel out. But we're going to get rid of it, because we're going to address the booster signal problem by getting rid of all of this dead space. All of this space, any space that is not directly like in the sight of the venturi itself is dead space. Now, to a point. we still want a funneling action, right? We still want a taper. We still want it to be funneling down to the venturi, because that's what gives it the venturi effect, is air has to squeeze down into a tighter opening. That's what speeds up the air. So we don't want to just straight wall it up, because that's not going to benefit us. We want it to be tapered. But still, having a taper, look at all of that dead space around, right? We can eliminate that dead space, forcing the air to come down into the venturi more up and down, and that's going to give the boosters a better chance at getting air to go through them. Now, like I said, ultimate CFM is not the goal. Booster signal is. Doing that, actually restricting the venturi opening so air cannot get past these boosters and around these boosters as easily as they can now, is going to hamper CFM. It's going to constrict the flow going through the carburetor. Okay, so that's not going to gain us CFM. That's actually going to minimize CFM. But, like we want, is to have a better functioning carburetor, not necessarily just one that flows a lot of CFM. We want the carburetor to flow good CFM, but we want it to be having good responsiveness while it does it. Okay? So, in terms of what mods we're doing there, might inhibit, actually lose us some CFM, but gain us some actual performance, because it has a better draw on the boosters, and better draw means it's more responsive and it'll atomize the fuel better, ultimately probably making better power because of the better atomized fuel. Also, right, there's one more thing that goes along with this that is going to be kind of unique. Not that filling a carburetor full of JB Weld isn't already unique, but there's one other aspect to this we got to address. Now, as we fill this carburetor up with JB Weld, because that's the plan, we're going to fill it with JB Weld. I got, liquidy JB Weld here, along with some stick JB Weld to actually, build up some walls around, because we're going to JB Weld all of this out here too. We want to give ourselves plenty of area, like plenty of space, so then we can come back in and port the top of this carburetor to the shape we want it. We're essentially filling it and then porting it to our own design. Can I help you? Yeah, well, I'm explaining what we're doing here. No, you don't need to. That JB Weld is mine. You get out of here. So, in doing that, there is one area, well, really two areas that we got to address. And that is being the accelerator pump, which happens to be on this side. It's a vacuum secondary, so this side will be easy. This side, we're going to have to address that fact. And the air bleeds here, because that's going to be a problem. Now, why is that a problem? Because if you look around, from here all the way around, right, we have plenty of open area. We can essentially do whatever we want around in here, in the middle here, and around here. But we are limited to what we can do because of these air bleed locations, okay? Well, here's the deal. We are going to JB Weld over these air bleeds, completely forget that they're even there, and make this opening whatever way we want it to be. Not caring about this in the slightest. This, we're going to have to address somehow. I kind of want to raise this booster up to the top. Not booster. This is a discharge nozzle, accelerator pump discharge nozzle. I kind of want to raise it up. But then again, I kind of don't. I kind of want to keep it where it is. So, I think this is going to be a sacrificial booster. Why do I keep saying booster? It's an accelerator pump. It's going to be in a sacrificial accelerator pump, and we might just JB Weld it in place. And that's, that is what it is, right? This we'll make sure it functions, but it's going to be in there forever. I don't know which way I'm going to go with that yet. This carburetor ultimately is not going to be run. This is just, we're testing it for on the flow bench to see what all of this crazy modifications do. So, I mean, it doesn't, you know. But anyways, air bleeds. What in the world are we going to do about that now? Because, yeah, sure, I mean, the accelerator pump discharge nozzle, I mean, that's going to be a debacle. But, I mean, you can work around, we can figure a way around that. And we can figure a way to modify that and make it work, well, the way we want it to. But completely JB welding over these air bleeds and, well, ultimately porting them out and just, you know, opening up the surface opening of this carburetor, I mean, that's unrealistic, right? I mean, you have to have those in order for the carburetor to function, right? I mean, we can make this work. I mean, ultimately, if, you know, I had more tools than just this file, I could probably machine this down and, you know, make it work and make a new pedestal for it up here and drill down and do all that stuff. That's a workaround. We can work around that. We can actually utilize that in the real world. But what about the air bleeds? What are we going to do? Where are we going to get our air bleeds from if we're completely disregarding them here? Okay. So there's 2 air bleeds. Well, no, there's 4 air bleeds on each side. There's 8 total. But there are 2 spots where the air bleeds come out. See, the air bleed up here, right? Bam. The air bleeds up here come down to holes down here. There's one hole there, a hole there, a hole there, and a hole there. So those are just holes. The actual metering of the air bleeds, the actual, like, you know, how big the air bleed is a pressed in brass stud. You can barely see the color brass in there, but they just press in a brass it's not a stud. I am having a hard time with the English language today. My vernacular is off. They just press in a brass thing in there that brings it down to the orifice size they want. The actual hole, you know, the rest of the circuit doesn't matter how big it is, really, because that's the actual size of the jet opening, whatever. Okay, that's in the old style. The new style have screw-in air bleeds. Okay, they have an actual air bleed jet that you screw into the top here, and that's what meters the amount of air going through it. Well, we are going to change this old style to accept newer air bleeds, but not on the main body. You know, everybody, I mean, it's a very common mod. There's 2 different places that you will do this mod traditionally to convert this to screw-in air bleeds. The first thing is to just drill out the area here, tap it, and then you can screw in the air bleeds in the traditional spot. That's the place number 1. But then there's a second place. What you can alternately do is just drill out these brass metering tubes. Just drill those out, you know, just drill them out. Then you drill these holes. You drill and tap those holes and put the actual jet in here to meter it. That's way number 2 to do it. Well, we're doing it number 3, right? We're not putting screw-in air bleeds in the actual main body at all. We're putting them in the jet itself. Now, let's just taking a look at this, right? You know, trying to wrap my brain around how in the world we're going to do this, because I want to have access to where the air bleeds are. I want to be able to make a nice ported entry into the carburetor. And in order to do that, we need to get rid of those air bleeds. So I was looking, and, well, I mean, clearly, the air bleed holes line up with this here, that's the emulsion circuit, essentially, right? Right there. All it does is just, it's just an open hole that goes into these spots from the main body. Those main body holes, they just meet up with that circuit. So instead, what we're going to do is we are going to actually drill the top of the metering block itself down, going to make a hole down into this circuit from the top. Okay, you probably drill it at a little angle like that, right through. Drill and tap the top of the metering block to accept the screw-in air bleeds. Now that's something I've never seen anyone do before. Is there a reason for it? I don't know. Now, clearly, we will have to make room for them, because if we do that, as you can see, the actual main body covers that area up. Easy fix. We just, either drill a big hole over top in this main body itself, which wouldn't be a bad idea, really. I mean, then we could port the hole, have little mini velocity stacks built in to the air bleed emulsion circuit, right? I kind of like that idea, actually. I think that's the way we're going to do it. Otherwise, you could just kind of mill this section off, and just expose it like that. But I like the whole mini venturi idea. That's the way we're going to go for it. So we're going to have our screw-in air bleeds up top, and then we'll drill holes in here so that it's not, covered up. This is crazy carburetor modifications, let me tell you. But what that does is that completely eliminates this whole thing right here. The emulsion circuit is not reliant on the main body anymore. And that way we can cover all this up, and we can make a nice big velocity stack like entry into the carburetor. Whew. Wow. That is basically the top side of this carburetor modifications done and explained. And we're still got the bottom to talk about. Now on the bottom side, what we're going to do is we're going to replace this 600 base plate with these small butterflies with a 750 base plate with the bigger butterflies. Now if you can't really tell, I mean you can tell a little bit on the size difference, but here's the real telling part. If we open this up, and I'm surprised it even opens, but you can see that's the difference, right? We are going to go and we are going to port the bottom of those bores and match it up to this 700 or well, it's actually a 750 base plate. And I've already pre-modified this one even shittier than I did that one. So I mean that's great. We might address that. I'm not so sure. I think the big bang for the buck is going to be all the other stuff we do, though. Not so much just that. Now we could just leave it like that with the bigger butterflies. I feel like actually porting it is going to be the ticket, though. That's the way it's going to work the best, is when it's actually ported to match. So we're going to have a 750 down below, a 600 up top with a completely new top made out of JB Weld and porting, and getting rid of the crossbar. We might thin down the once we port this, we might thin this whole thing down just a little bit. We'll see. I don't know. And ultimately, well, that's the plan for stage 2. This is stage 2 now. So, what do you think? If stage 1 made so much of a difference on this thing, I can't even predict. I couldn't predict what stage 1 was going to do. I thought maybe, 15 CFM, 35 CFM. maximum 50 CFM, maybe gaming out of it. Go watch the video, okay? Figure out how much it was. Quite a bit. Quite a bit. But this, I have no idea. Like I said before, the fact that we're filling a lot of this in is probably going to reduce CFM compared to what it is now. But then you got to take into consideration, we're not only filling all this in, but we're getting rid of all of this dead space, right? And we're making a very nice transition into the carburetor. We're essentially building 4 mini velocity stacks on the top of the carburetor as the entry to the carburetor. Very nice flow with long radiused entry points, right? That's going to pick up CFM, I do believe. But is that going to pick up more CFM than what we lost by constricting the entry's actual port diameter? I don't know. Are we going to make it up by getting rid of this crossbar and doing a little work on the actual booster? I don't know. How much is putting the bigger butterflied 750 base plate on it and actually porting all of that to accept it? So you have a bigger bottom to the same venturi size top? Is that going to increase booster signal in of itself? I don't know. I have no clue what this is going to do anymore. I can't guess because air is fickle and it does what it does and it wants what it wants. And all we can do is try to predict what that is. So that's it. That's the plan we're going to do with this thing, right? I'm going to get started on it. I mean, we got to fill the thing with epoxy, first of all, you know, this stuff. That's going to take a while. Once we fill it with epoxy, then we'll do another update video, and we'll start porting on it, making it the way we want it. We'll not drill out, we're going to use the drill and some sandpaper and stuff, but we'll port out the bottom of these bores so that, you know, that all lines up. And we can make a metering block the way that I, you know, am planning on making it, just to prove the point that it can be done like that, right? Obviously, we don't need the metering block in order to flow test the carburetor, but just as a proof of concept, you know, that way we can justify our meddling with the original air bleed locations. So, take your bets. I have no idea. Is it going to be better? Is it going to be way worse? Is it going to surprise us? This started out as a 600. What's it going to be now? I don't know. We'll figure it out. But until then, I'll catch you next time. I'm telling you, I don't think anybody has modified carburetors as much as me at this point. JB Weld the entire top side of the carburetor. Now that's some good fucking YouTube right there.